Let's start off with a point. From this point we can draw a line. Now if we were to grab another point, we can draw a triangle. So a triangle is going to be given by three lines which have been joined together at their ends. Now you can open this simulation up in the resources section and you can play about with it and generate whatever triangle you would like to generate. Now we give different triangles different names. So if all of the three lengths of the triangle are equal, so for example here, this length here is equal to this length here is equal to this length here, then we call that triangle an equilateral triangle. If only two of the lengths are equal, so for example we could draw a triangle something like this, and we can say that this length here is equal to this length here, but it's different from this length. So only two of the lengths are equal. Then we would call this triangle an isosceles triangle. Finally, if all three lengths of the triangle are different, so for example here, when this length here is different from this length here, and it's different from this length here, we'll call this triangle a scalene triangle. So these are our three types of triangle: an equilateral when all of the lengths are equal, isosceles when only two of the lengths are equal, and a scalene when none of the lengths are equal. Now when we look at a triangle, we are not only interested in lengths, we're also interested in angles. Now, most people probably have an intuitive understanding of angles. For example, if we were to look at this triangle here, we could say that this is a large angle and this is a small angle. In fact, we can make this angle even larger. So this is a very large angle and this is a small angle. And we can adjust the point here to bring this angle down. And when we make this angle smaller, this one here becomes larger and this one becomes larger. So let's investigate the idea of angle. We're going to go back to a line. And we're going to have that line rotate around in a circle. And when it rotates around in a circle, it's going to rotate round by a value of 360 degrees. So let's see that now. We will draw a circle around our line. One end of the line is the centre of the circle. The other end of the line sits on the circumference of the circle. And we're going to rotate this point around the circle in order to generate some angles. We're going to start off with a reference point, and this reference point defines our 0 degrees. So we're going to start off at a value of 0 degrees, and we're going to rotate around the circle in an anti-clockwise direction. Now when we rotate around in an anti-clockwise direction, it creates a positive angle. So for example, this angle here is an angle of 57 degrees. And as we rotate around the circle, the angle gets larger and larger. And you can see that if we join this point to this point, we're going to have a triangle with an angle in here, in this instance given by 68 degrees, and as we increase it, we get to a point where we have something called a right angle. So this right angle is a value of 90 degrees, and as this point rotates round to this point here, we'll get an angle of 180 degrees, and then an angle of 270 degrees, and all the way round to an angle of 360 degrees. But notice when we go round all the way around 360 degrees, this point gets to the same starting point. So in effect, when we've gone round 360 degrees, we've gone back to the beginning, which is 0 degrees. We're going to be interested in right angle triangles for the moment, and you can see here a set of right angle triangles being generated. The right angle is here, and the other two angles are here and here. And you can see as we move the dot around the circle, we're going to generate lots of different right angle triangles. Now in the next video, we're going to cover something called Pythagoras theorem, and it relates the lengths of the lines of a triangle whenever one of the angles is right angled. And we'll go on to that in the next video.